Today on the bench I have my FT-817ND, which I bought second-hand a while ago, probably a couple of years ago. Yeah, and it was for the owner it was perfect, but actually it was not. Happened that the output power was only 2 watts instead of 5, and other few things. Now yesterday I was using this radio for some checks on a small power amplifier, and I've noticed that there was a problem on FM. So I thought I'll go through full adjustment again and see how it performs. I've got the service manual on the side, so let's start. Okay, we start powering up the radio with an external 13.8 volt, which coming from the power supply. Is on air receiving mode now is 330 milliamps. Really is on and opened. And we start checking the reference oscillator, and which is this board here. So we have to adjust TC 5001, which is the red one. This one here. For 67875 plus minus 10 Hertz. And also checking on pin 2 that we've got a reasonable signal, but obviously we have a good signal, otherwise the radio wouldn't work. So let's warm up the frequency counter up there, and let's check the reference. This is the circuit diagram of the ref unit. I'm gonna probe the pin 1 and pin 2. I'm gonna probe the pin 2 with using 1 as ground, and yeah, here it says should be 90 millivolt RMS. I'm checking now the frequency for 67, as we said before. 67875 plus minus 10. Okay, this is the schematic, and before we take the measurements, it's worth to mention one point. Looking at the schematic, and let me get it close to the radio. If you look at the schematic and then you look at the reference unit, you might think, because you've got the 3-pin connectors on the left, the 4-pin connectors on the right, you might think that this is reflecting the actual pin out. So we've got 3 grounds on the left, and that's okay. And on the right we have ground, reference, 5 volts, 5 volts. So you might think that the 4 pins are ground, reference, 5 volts, 5 volts. But actually it's the other way around. This is ground, this is reference, and these are the 5 volts. And if you look for this white dot here, same white dot here saying this is ground. You want to look at the layout, which now is the other way around. So we've got the 3 pins on the right and the 4 pins on the left. So ground is this pin here. Yeah, that's just worth mentioning because I got confused myself as well. So I want to check that we've got 5 volts here and the reference signal here with at least 90 millivolt RMS and the frequency of 67875. So let's go and probe these pins, and we've got 5.02. Let's probe the second pin just to check if they are together. Yeah, 5, 0, 2. Okay, that's fine. Now let's check with the help of the RF millivolt meter and its probe. Let's check the level. We could do this with the oscilloscope as well, but I like to use the Boomton. So probing pin number 2, I want to see at least 90 millivolt. I'm on 100 millivolt scale. We've got full deflection, so we are good there as well. Now let's check the frequency. Okay, so the quartz, the oscillating quartz is 22.625. So this is what we will get here on this pin. And let's check that with the oscilloscope. We've got 22625 with this wave, about 87 millivolt RMS, but it's okay. Probably a little bit of attenuation by the oscilloscope bandwidth. So we should have 67875 on the pin 5 of Q1038. It should be this one, so let's look for it. It should be, let me see, it should be just on top of the filter. It should be this one. Should be this one. This should be pin 5. So let's check that. Now this is here there's another catch. This is Q1038, and let me get the light. And pin 5 is this one here, and there's a test point here on pin 4. Sorry, pin 6. If we take a look at the manual, I have on page, sorry about that, page 37, I have the schematic. This is Q1038. This is pin 5. There's a test point there, but actually I don't see the test points in the board. Now if you look at the If you look at the layout, by the way, this radio is lot. This schematic is for lot 75 and above. If you look at the board layout, 1038. I don't see this test point that I have, and I see a bigger component, a bigger IC. This 1038 looks bigger to me, much bigger. If you look carefully, the dimension, this is almost touching this, and very close to this, and there's not much of a gap between the coils. But if we look on my board, yeah, the component should be much bigger, and in fact it's not. So I went and looked at the board. The board is labeled number 8, while this layout is labeled number 6. So it's not exactly the same. Q1038. Let's have a look at the component. This is the Q1038. It's got the pins that go through the board, which is not the case. This is more like SMD. And this is SA602A. Doesn't look the same component. So the component I have in the part list is only this one, SN16913P, and I don't have any other board layout. The other ones are previous versions, so the manual I have is version B. So maybe I'll try look for a newer manual. So this radio must be one of the last in production. Meanwhile, looking for it on internet, I found a picture of a board labeled number 2, version 1, and this is the component. You can see how bigger it is, and it's through hole. Just wanna show that. Okay. Also, another thing I want to mention is that here the alignment procedure talks about pin 2 60 millivolt RMS on the connector here. Okay. But I said previously, I said 90. In fact, if you look at the ref unit itself, which will be about here. If you look at the ref unit, here it talks of 90 millivolt RMS. So I'm saying this just to advise that these manuals are full of errors. Not all the times, but they can have a lot of errors. And I have gone through adjustments also for my FT-1000 Mark V field, and I found a lot of errors there as well. Okay, so I have realigned the reference oscillator. Just let me get. $22,625 thereabout. Okay, it's good enough. And now with the PLL phase adjustment, connect the voltmeter to pin 6 of connector J2002 and refer to the table below. So pin 6, this is the PLL unit. J2002 pin 6 is this one in the middle, so you have to take the cover out because the connector is here on the right side, and we're connected on J6 on pin 6. Okay, let's switch on again the radio, and we want to tune 13895 on CW. $13,895. On CW, and we must have 4.5 between 4.3 and 4.7. We've got 4.64, so we are within tolerance. Then we tune 76 and we confirm at least half of a volt. Seven six. It's okay. You can't change the mode here. It's another error. You can't change the mode here. It's wide FM. You cannot go to CW mode. At least 0.5. We got 0.51. Okay. Now we go on 29,995. Uh, 29,995 CW. Lock the VF4 just to avoid errors. We should have again 4.5. We've got 4.51. Tune 13.9. Confirm at least 0.8. $13.9, and we've got 1.2 basically. Okay, and we go 53,995, 53,995, and we look for again 4.5. Plus minus 0.2, we got 4.6 within tolerance. We go now 88 megs. Should have at least 0.8. We've got 0.811. Then 146. 146 CW. We should have 4.6 plus minus 0.2, so between 4.4 and 4.8. So we are a little bit low here. And then on 144 at least 0.5. Well, we have much more than 0.5. We have 4.13. So doesn't look correct to me, but anyway. Then 440, 4.6. For 4.6, and we've got 3.5, and 430 at least 0.4. I've got 2.65. So it looks like VHF and UHF need some adjustment, even though the radio works. So let's go back on 2 meters. Okay, so going back on 146 CW, looking for 4.6 plus minus 0.2, adjust L2010. Now L2010 is this one here, and guess what is this one here. So we should probably try and move the turns just a tiny bit. We've got 4.37 now. Minimum is 4.4, so we are very close there. Probably, well, actually, it's not an issue because the radio works and the PLL will lock. So I guess I will not touch it. Well, just squeezing the turns a tiny bit with 2 screwdrivers, one on each side, and pushing them against each other. We raised to 4.43, just a tiny bit. So we are now within the tolerance. It's a very weird adjustment though. And for the 440, we should have 4.6 again. And we should adjust L2011, which is the tiny one on the right. So this one here. Let me have the voltage in the shot. Look, as I push a little bit on the turns, look how the voltage changes. But we're a bit far from 4.6. Okay, what I have found is that the pin 6 has got a connection to a test point outside the shielding, which is this pin, this point here, and as you can see, we can read the voltage. Having the shielding well closed, because this is having an influence, and also there are just beneath, there are the holes for the adjustments, Okay, obviously these three, but also these two holes for adjusting the two inductors. It's not easy though. Probably you need 3 hands. You have to check the voltage in there and look, and meanwhile adjust. Okay, so still on the PLL. So basically, as I said, there is this test point here. They don't talk about in the description, but we can see by the layout that in fact we are on the PLL unit, and this is the J2002 connector, and 1, 2, 3, 4, 5, 6. The 6th pin is going out to this test point 1007. Okay, now what we found before was that let me get the manual again. So was that they want us to have 4.6 volts at 146 megs at and 4.6 at 440. Now, if we go take a look at the schematic from the from the manual from the 817, because we had, instead of 4.6, we had less, no? Just for the 2 meter band, just on the edge, 4.3, and for the 70 centimeter band, we've got 3.5, something like that. So if we go take a look at the manual for the 817, not the ND version, we see that that here we have different values. 3.8 with at least 3 volts for 144, and 2.4 with at least 1 volt. So I have to find the frequency. We are not sure which, if there's any error in which manual is saying the right things. So probably because there's an unlocking situation. If we go, you see, and this goes up to 470, and the last megahertz gets an unlock state, gets into unlock state. So I have to probably fiddle a bit around this coil and see what voltages are good for the PLL to lock on the entire 70 centimeter band from 420 to 470. Okay, on 440 now, we read 2.45, which according to this manual, which is the ND, and this is the ND of course, according to this manual should be 4.6. I got 2.45, which is in the range for the 817 first version, 2.4 plus minus 0.2, so between 2.2 and 2.6. Confirm at least one at 430. So 430. We've got 1.7. Okay, but the most important thing is that now we have a lock on all the frequencies, also up to 470. That's what matters most of any other guidance. So I had to give it a bit more space. Let me get the lens in. I had to give a bit more space to the coil. this coil on the right, if you see, there's a gap between the left turn, the first turn on the left. Let me get a pointer. So there's a bit of a gap here between the first turn on the left and the second and third. So I put the screw in the middle to give a bit more space. And just doing this, it will adjust the voltage. So we check again. 2.46. Okay. And yeah, so that's done. And by the way, these two coils I was adjusting are L2011 on the VCO 4 and on the VCO 5 and L2010 and the VCO 4. Regarding the 2 meter band, this manual is saying 4.6 volts. The 817 manual says 3.8. And I have got on my unit, as we measured before, sorry, I'm not a 146. 146. I read 4.34. So it's somewhere in the middle. It's just low on this and high on the other manual, but it works. So locks everywhere up to 154. So I will leave it like that. What we check now is the first local output level, and to do that we are once again inside the PLL unit, and pin 11 is going to be this one here, this one with this this strip going to this SMD component. This is the output. I want to check that is at least 5 dBm, 28 megahertz on CW, 28 CW. So the first intermediate frequency is 68.33. So in fact, let me get a max hold. Let me get a measurement with a spectrum analyzer. Okay, so I got a measurement, and as you can see, we are on 96.33, which means the frequency is correct as 96.33 minus 28 gives us the first IF 68.33. The level is minus 5 dBm instead of plus 5, but we are terminated at 50 ohm, so probably it's lower than what they say. Let me have a look on the old manual. I'm probing now with the millivolt meter, and I'm getting I'm on the plus 10 range, as you can see. We're getting 0 dBm. So yeah, 9.8. Okay, so the level is obviously good. Next step is a PLL unlock alert. I want to check that. So we connect the voltmeter to the pin 1, which is the first pin here, and then disconnect the 4-pin plug on the ref unit, which is this guy here, and we confirm that we have less than 0.5 volt on the voltmeter and an unlock on the LCD. Then we reconnect and confirm that the voltmeter shows at least 3.5 and the LCD returns to normal. If we start from the end, where the ref unit is connected, we want to have at least 3.5 and the LCD in normal conditions, which we have. LCD is normal, and we've got 5 volts. Now, and by the way, I'm probing that first pin. Now, if we disconnect the 4-pin plug here from the ref unit, this one here, I'm sure I can do it on the fly. I will do it. So we've got, we have to have the display showing unlock and less than 0.5. We've got 0, and the display is in an unlock state. I'm keeping this out. If I push it back in, we are back on 5 volts and the display is fine. Now, for some reason, we go now on the PA unit adjustment, where we want to set the idle current for the driver stage and the final stage. But yeah, we should. Yeah, the radio is upside down. Final unit is here, which is this one here. So we should desolder a jumper, which is in here, and then use these 2 variable resistors to set the idle current for the drive and final transistors. But I'm not going to do that because I have done already, so I'm going to skip this part. You pardon me, but not willing to do it again. I have checked this part already when the radio first arrived, because when I checked the radio after I bought it, it was delivering just 2 watts, so I had to go through also the transmit alignment and checks. So if we skip that, we go on the next page where we have the second local oscillator adjustment. The second IF is 455 kilohertz. So let's deep into. Okay, so for for this adjustment, they say to look for pin 5 on Q1038 and adjust these 2 coils, 1024, 1026, for maximum level, at least 120 millivolt RMS. Now 1038 is this one, pin 5. Here they say 200 millivolt RMS, where in the description they said at least 120. Okay. I got 80 millivolt RMS. Unless maybe I'm loading a bit the circuit with my probe. Okay, but also the difference I have with this manual is that my Q1038 is not an SN16913, but is an SA602A, and this one's got two outputs on pin 5 and pin 4. And if I probe pin 5, I get nothing. The level is on pin 4. That's the first thing. The second thing is, second step, for this step they say to probe on pin 5 of Q1055 and adjust coil 1021. So pin 5 on Q1055. So 1055 is this one, pin 5 is this one. If you look at the layout, this is 1038 and this is 1055. So 1, 2, 3, 4, 5, this is pin 5. Now if I probe pin 5, I don't have, first of all, once again, I don't have these ICs. I have SMD ICs, different types. It looks like I have this one, a 2594, and pin 5 is signal input. But first of all, the orientation is different on mine. So as you can see here, pin 5 is facing the front, the filter. Okay. Sorry, this is pin 1, okay, and pin 5 is this one. If you go look here on the description, when they say to probe pin 5, they show you here the 1055 with this magenta line. It says Q1055 pin 5. Okay. So the orientation we see here, the dot, the orientation is 1, 2, 3, 4, 5, 6, 7, 8. Now if you have a look at my component, it's the other way around. So here is pin 1 of my component, 2, 3, 4, 5, 6, 7, 8. Okay, so if I probe pin 1, in fact, in accordance with this data sheet, I get 5 volts DC. But anyway, what I have found on the schematic is that this Q1055 pin 5 goes to this coil, Tango 1021, and there's a test point here, 1056. And in fact, in the description, they say to adjust coil 1021 for maximum deflection on the RF millivolt meter, at least 70 millivolts. So if we look for, if we locate, the other file, if we locate the coil 1021 is up here, and the test point 1056 is this one. So I'm gonna probe here to look for the level, and if we need, we try and adjust this coil just in case we need to pick the level. To show you what I just said, this is Q1038, so I had to probe instead of pin 4, I had to probe pin 5. Instead of pin 5, I had to probe pin 4. And you can see it's SA602A by Philips. Okay, and this is 1055. And you see by the dot, this is pin 1, where in the manual is expected to be here a through-hole component with pin 5 on the top left. If you got pin 1 here, and pin 5 is this one. But anyway, instead of going here, the pins are very close to one another. Instead of going here, I have gone to here, the test point I mentioned before, and this is the coil 1021. So we want to have at least 70 millivolt RMS here. Now let's probe the point and take a look and adjust the coil if that's the case. Okay, so I am probing now on TP1056, and obviously I have lost the contacts, and on the 300 millivolt scale I've got 180 almost ish, 180. It's not critical. I just want to check that is at the peak, moving the 1026 coil. Unfortunately, I only have 2 hands, so I have to do it off camera. So I got the help of somebody here next to me. So I'm probing now. She's taking the shot. We've got the 180 roughly. I'm gonna move the coil now. So there you go. So here we go down, and the other way around we go down. So we were already at the top, huh? Let me go back at the top. There you go. That's it. Okay, now we move on, following the steps, to TX IF adjustment. And we want to tune 1.8 megahertz on CW mode. Connect the millivolt meter to J1002. Terminate into 50 ohm load. Key the transceiver and adjust 3 coils for maximum deflection. So the transceiver is a 1.8 megs on CW. J1002 is this one, is disconnected. And what I will do, this is the millivolt meter probe. This is a 50 ohm termination. I'm gonna use a short cable into, and I'm gonna put this. I'm gonna probe the center pin on J1002 here, and as I key the transmitter, we will adjust 1020, this one here, 1005, and 10012. So I'm gonna reposition the camera over pointing the millivolt meter, and we're gonna try and find the peaks. Okay, probing the J1002, and now key the transmitter. Okay, we are on a 300 millivolt scale, the one on the bottom. So we are reading 245-ish. As I move 1020, we see that we've got a movement on the needle, but we are already at the peak here, 245. Okay, so this was okay. Now let's check the other 2 coils. This is 1012. Oh, this one needed to be peaked. As you can see now, we are at 265, and let's see 1005. Oh, nice. 280. Nice. Good. Just want to say something about this this process. Using this cable was not the best because, as you can imagine, these two leads like this are not keeping the 50 ohm impedance, but it's a relative measurement, so we want to find the peak, not the absolute value. I have a couple of these connectors. These are called TMP, Tango Mike Papa connectors, and I found some, and they're also fairly expensive. And then I've got some coaxial cable from a board, which is this one here. So I'm going to use this cable. Probably I'm going to cut it half and put the connector on one side, and then join maybe a BNC male to the cable, so I can then use that cable where I need to. Next step, FM adjustment, 29 megahertz FM, same probing point on the J1002 connector. Adjust this time T1012 and 1013. 1012 is the same as this one, so we might want to recheck, but maybe it's not needed. And 1013 is just on the side. So this was 1012. Before we picked this one, and this one. Now we want to pick this one and this 1013, so especially 1013, as we picked already this one. So for maximum deflection, once again on the RF millivolt meter. Then we will go on 2 meters and make a different adjustment for frequency. Okay, probing the same point, ready on FM, 29 megs FM. I want to adjust this one, the second coil from the left. Okay, and if I go on transmit, let's see what we get so far. On the 300, we've got 180 a bit. Okay, so let's tweak the coil and see what we get. Okay, I didn't have any improvement on that, so I tried to move left and right, but that was already a peak, 180-ish. So good enough of that. So next is this coil here, Tango 1018, next to this quad. So we want to go on 2 meters, 144. 144. 144 FM. Okay, let's be precise here. I got it fast, that's why. The fast, okay, it's with the button on the microphone. Okay. Oh gosh. I can't get 144. There we go. 144 FM. And we want to check the frequency. So 244 FM, keyed the transceiver in FM mode without the microphone input, and adjust Tango 1018 for a reading of plus or minus 100 Hz on the frequency counter. Let's do that. I'm gonna use this frequency counter as the Marconi. It's got an open control oscillator, so it's quite stable, and it was already calibrated. It's precise enough. It's yeah, accurate. Okay, ready. This unit is not the high stability anyway, so I'm not looking for a super precise measurement, but we try our best. Okay, So what have we got here? 144. This is the frequency I want, and this is the offset that we get from the radio. Minus 50 Hertz. So if I go and twiddle that coil, on the other side, let me go on bar charts. Don't need the spectrum. Yeah, -2, -1. Yeah, pretty darn close. Maybe I will put it a bit higher because when it's closed with the covers, it will get warmer, and also it's quite cold now here. So just a little bit higher. No, I'll leave it like that. It's fine, an FM, no problem. It's spot on anyway, 144, okay. No offset basically. That is also done. The microphone was turned all the way down as requested by the this adjustment. And then we go on carrier balance adjustment. Carrier balance adjustment, terminate. Still the same point, same setup as before. Killer transceiver on USB on 28 megs, no microphone input, and adjust VR 1001 for maximum carrier suppression on the spectrum analyzer, or for minimum indication on the RF millivolt meter. So because I'm using I'm already set with the millivolt meter, I will use that one. And by the way, VR 1001, the one we have to adjust, is this one here, which means on the board it means this one here. You can see it's marked VR1. So let me set the camera. Okay, ready again on 28. I don't know if you can see something there, but we're touching the -50. So if I go and transmit and try to adjust, oh, this one is too big. Let me get the right screwdriver. Let me get a faster sweep. Yeah, it's not that easy with the we are already at the minimum, but spectrum analyzer has some noise on the signal, so probably would be a bit easier with the millivolt meter. Okay, I have done that step with the RF millivolt meter, and basically was already at the minimum. So that is also out of the way. Now we've got VHF and UHF bandpass filters. So 145.995, same connection on J1002. On FM, adjust 1011, 1010, 1009 for maximum indication. So let's locate those three coils. 1011, it's this one here. This one here, 1010 and 1009. So those three here, which are those three here. these 3 cans. So let's set up again and check also this. Okay, done. Okay, UHF 439995. Same setting, transceiver on FM, and just TC 1002, 1004, 1005, which are just next to the coils that we just saw. These 3, which are these 3 in blue. Okay. And we are ready on 439995 on FM. Okay, I've done this type of camera because couldn't get. I was fiddling with this adjustment because these three capacitors are fairly flat, and my screwdriver, as you can see, doesn't fit exactly. It looks like it fits exactly, but actually it's a bit bigger. And as you as you make a bit of pressure over it, you change a bit the value. Also with some capacitive coupling, it was the needle was moving a little bit up and down. So I had to a bit of fiddling with this adjustment, but nevertheless it's done. It's done now, and what can we say? That we have arrived here. So at the end of TX adjustments, now we've got RX adjustments, which will come in the next video. I guess I will stop this for now here. So thanks for watching this first part, and wait for the next.